¿Cuánto quieren? ¿Cuánto más o menos quieren? Uno. Ya. Okay. Organizers of this meeting for inviting me to give this talk. I'm Andrés Rivera. I belong to an institute in southern Chile called SEX, but I'm also a professor at the Universidad de Chile in Santiago. So today we'll talk about climate change and Antarctic glaciology. Antarctica is a huge continent, and you have many different regions, like, for example, the ice sheet in the interior. You have sea ice, you have, for example, this photograph from Fields Bay here, and also Patriot Hills, where we are landing with huge airplanes like C-130 or Illusion. So when we talk about Antarctica, we talk about many different regions and different responses to climate change. So these are some of the questions we would like to answer with our research. We are talking about natural variability, or we are talking about human-induced changes. What is the role of mankind in all these changes? Or we are talking only about the natural variability. We know that the climate has been changing at least during the last million years. So how mankind is affecting such a variability, this is one of the answers we would like to have. But also, what is the response, and if the responses of the Antarctic glaciers is connected to these climate changes, or there are some dynamic components, or if the glaciers are responding not to the climate changes in, let's say, in the last century, maybe changes in the last millennium. So that kind of things we would like to answer with our research. But probably you are more interested in the consequences of the behavior of Antarctica. What kind of changes we will suffer on Earth, for example, sea level rise, for example, scarcity of water resources, etc. So, and finally, what kind of forecast, mitigation, or management we can establish in order to confront all these consequences, all these processes. These are some of the questions we would like to answer. Let's go to the meat. So we have here the atmospheric temperature in the last 120 years. This is mainly records from stations. And you can see a clear warming trend for all the period, and which has been accelerating in recent decades. And the uncertainties are also reducing, because obviously at the beginning we had very few stations, but now we have much more stations. So we are more confident that all these changes are taking place. But this is the global picture. But if we go to different regions, not all Earth is warming at the same rate. It's not an equally distributed warming. And that's important, because you can see here in these colors that some areas are warming very fast, but even some areas are cooling. So obviously, if I'm, for example, here, you would say, wow, there is no global warming. But this is maybe not the best example. But if you analyze in detail what I'm showing here, we are in one of the hot spots of global warming. This area in the Antarctic Peninsula is suffering one of the highest atmospheric warmings on Earth. The global warming is about 0.5 Celsius degrees. But in this region, we have stations showing warmings up to 6 Celsius degrees. For example, this 6. So, for example, here, Bellinghausen station is measuring the temperatures, and it's showing 3 Celsius degrees of warming trend since 1968, the beginning of the measurements of this station. But this is not the only one. Faraday, Rothera, and other stations in the same regions are showing warmings up to 6 or 7 Celsius degrees. So we are now in one of the hot spots of global warming. But the rest of Antarctica not necessarily is responding in the same way. So what is driving all these changes? Well, we know carbon dioxide and greenhouse gases are increasing. Here in red you have all the measurements from data, for example, from South Pole and from other stations like Mauna Loa in Hawaii, and it's showing a clear increment in carbon in CO2. But what is the global picture? If we go back to 1,000 years, we can see that clearly we are in the maximum for all this period. But if we go further in the past, if we go to 400,000 years before present, using ice core data, for example, this one from Vostok Station, Russian station, also we can see that the CO2 has been not homogeneous during all this time. Obviously, it has been fluctuating in the last 400,000 years. But now we are in absolute maximum in comparison with all this time. let's go to another greenhouse gases. It's methane. And if you see here also data coming from ice cores, and you can see that now we are observing almost double the average methane fluctuation in the last 400,000 years. So what we know about temperature? We know that CO2 is increasing. We know that this is connected with global climate. But how we can learn about this association? If we see here, you have CO2 and methane, and this is the reconstructed temperature for the same period of time. If you see, when CO2 and methane is high, temperatures are also high. When CO2 and methane is low, temperatures are also going down. So there is a clear connection between CO2 and these greenhouse gases and global temperature. And we know that CO2 is following changes in temperature. Therefore, what is the main message that politicians like you would like to know? That we are now observing concentrations of CO2 30% greater than in the last 400,000 years. Also, methane is very high, and this is affecting our climate. Siguiente. So let's go to Antarctica. Antarctica is a huge continent with almost 14 million square kilometers, 10% of the global surface of the Earth. 98% of the Antarctica is ice, holds 70% of the fresh water on Earth, 91% of the ice on Earth, and is equivalent to 65 meters of sea level. Well, if I'm God and I'm able to melt down all the ice, the global sea level will rise 65 meters. The mean thickness of the ice is about 2,000 meters, but in some places we Chileans, have observed more than 4,500 meters. And the velocities are very high. In some places not, like 10 meters, but in some places up to 2.5 kilometers per year. So in this picture you see the main basins, and in colors the flow velocities. And in some places, velocities are very high. Let's say here, let's say in some outlet glaciers in the peninsula and also in East Antarctica. So we're in the coldest, windiest, highest and driest continent on Earth. So it is a spectacular place. Siguiente, por favor. So, what is the climate change trends in all the continent? Well, you can see here in red, warming, in blue colors, cooling. And this is the peninsula, and you can see red, red, red. This is the hot spot I was talking about. But the rest of the continent, obviously there are very few stations. We don't have a lot of stations in Antarctica. But if you see the rest of the stations, there is not a clear trend. Even in some places there are some cooling. Yeah, especially, for example, in autumn or in winter. So there is not an homogeneous signal in this part of Antarctica. And that's why, for example, in last November, we went with the Chilean Air Force to this glacier here in Fleming, and we established a new automatic weather station just to measure what is going on, not on the northern tip of the peninsula, but further south. Siguiente. So we have different regions in Antarctica. We're just in an island, maybe 100 kilometers away from the northern tip of the Antarctic Peninsula, what is called Graham Land. But we have also East Antarctica, all this region here. We have West Antarctica, all this region here. And then we have the Antarctic Peninsula. And I will not go in detail because we don't have enough time, but Eastern Antarctica is more stable because the ice is supported by rock above sea level. If you melt down the ice, this will be a continent, mainly. But then West Antarctica is, the bedrock in West Antarctica, so the rock underneath the ice, is well below sea level. If you melt down the ice here, you will have an archipelago. For example, here in this part is Mount Vinson, the highest mountain in Antarctica, 5,500 meters. So if you melt down the ice here, it will be like an island with 5,500 meters. And then the peninsula, well, it's not clear, it's not here because it's too small here, but the peninsula is also suffering a lot of changes. It's the area where most of the changes are taking place, the peninsula. I will go in detail now. So the peninsula is about 7% of the total Antarctic area, but it's receiving 25% of the precipitation. It's a wet area, but inland you can have only maybe a couple of centimeters per year. You know, Boston, South Pole, all this region is very dry, but the peninsula is relatively is much wetter. But and it's holding only, let's say, 1/3 of a meter of global sea level. But the majority of the glaciers are retreating. Why? Well, because this warming trend I was talking about. And most importantly, the ice shelves, all these platforms like Larsen C, Larsen B, George 6, Wilkins, have been collapsing, some of them, and will collapse in the future if these changes are continuing. So here you have the temperatures. Esperanza is an Argentina station, Bellinghausen, the Russian one, Faraday, Rothera. So this is the warming trend in all these stations. So this is a very changing area, and that is why all these ice shelves collapsed in the recent past. This is, for example, Larsen B. Yeah, Larsen B was in this position, and in a matter of a couple of weeks, collapsed totally. And all the ice, more than 2,000 square kilometers of ice, went to the ocean as small pieces of chunks and icebergs. But also Wardy, the one we were visiting in November last year, collapsed in 1989. Larsen A collapsed in 1995. So I'm sure in the future, maybe you will listen about new ice shelves that will collapse. George 6, Wilkins. Remember these names because some of them will collapse if this warming trend continues in the future. Siguiente. And what is happening after the collapse? Because the platforms are floating. So they are not contributing to sea level rise immediately because it's integrated into the ocean volume. But if you melt down and if you collapse the platforms, the feeding glaciers, the glaciers that were forming, that were generating this platform like Larsen B here, all these glaciers accelerated and thinning very rapidly. The speed increase, and this process is contributing to sea level rise, and this is scaring, you know, because this is a feedback. It's a positive feedback. You increase the global warming, you increase regional warming, you increase the possibility of the collapse of the shelves, and then the collapse is taking place. The glaciers are speeding up. There are more collapse, more contribution to sea level rise, and so. It's a feedback, you know. It's a retroalimentación in Spanish. So this is the process we are observing now, and these are some images of this acceleration. So let's go to another region. Let's go to West Antarctica. And in West Antarctica, this region here, you have huge platforms like Ronnie Filchner Ice Shelf and the Ross Ice Shelf. But also there is another area called the Amundsen Sea Embayment. And we were interested in this area, and thanks to President Lagos here, we went with the P3 from the Navy in 2002 to fly from Punta Arenas to this area, and we were measuring together with NASA many areas here, you know. And then we discovered that these glaciers in the Amundsen Sea area were melting down, were thinning very rapidly. And if you see this picture, this is the elevation changes in Antarctica. Blue is thinning. White or yellow and red is thickening. And if you see Antarctica, it's not very clear the pattern. But here, you see a huge thinning. And this is because this area is responding very rapidly to this atmospheric and oceanic warming. And this is why this is the area more likely to collapse in the near future. And we're observing this signal right now at the moment. If this area is suffering what has been forecast, sea level rise can reach 1.2 meters. This is not, I'm not saying that this will happen next year, or maybe not in the next decade, but maybe in our lives, maybe I'm younger compared to some of you, in our lives, we will observe some of these changes. So, and this is scientifically based. I mean, I'm not speculating here. We went to this area and we did the measurements. So we know what's going on now there. So if you see, this is Pan Island Glacier. This is one big chunk of ice that calved in the past. But if you see the balance of all these glaciers in this part of Antarctica, all of them has negative mass balances. That means that the inflow, let's say the accumulation of snow compared to the melt and the calving coming from the glaciers is negative. So we are losing mass in huge amounts. We are talking here about cubic kilometers of ice. cubic kilometers of ice. And also the acceleration. Here you see on the left, 1974 velocities, and now in 2003 the velocities. Yellow is showing high velocities, almost 3,000 meters. So in 74 only a few spots, and now almost all glaciers are speeding up. That means more contribution to sea level rise. So, going to the conclusion, Antarctica is a continent of huge dimensions with different regions. Some of them are changing more rapidly. One of them is West Antarctica near the Amundsen Sea embayment area, and the other one is the peninsula. The peninsula is too small here for being included in this figure. But the whole of Antarctica, because you will say, well, okay, West Antarctica is melting, is going down, but East Antarctica maybe is rising, is thickening. So what is the global balance? Well, here you have the global balance. In the 90s was almost nil, was not losing mass, was not gaining mass. But now all estimations are showing that the Antarctica is increasing negative mass balances. That means it's contributing to sea level rise. Second. And sea level rise is a fact. We have measurements from tides and from many observations, and now in more recent years we have satellite data that is showing that it's going up. And you know, there are three main components of sea level. One of them is the thermal expansion of the ocean. And the thermal expansion of the ocean is coming from the warming of the atmosphere. If the ocean is warmer, it has more volume, so it's rising. This is the first component. But the second component is the contribution from the ice sheets, like Antarctica and like Greenland. Until now, nobody really knows what's going on with Antarctica and Greenland. But until now, I mean, 10 years ago, now we know that Antarctica and Greenland are contributing to this to sea level rise significantly. And then the third component are the small glaciers all over the world, and they are also contributing to sea level rise. For example, in Patagonia. But the amount of water is more, the most contribution is coming from the thermal expansion and from Antarctica. So Antarctica is very important to be studied in detail. So some conclusions. You have different regions. Now we are in one of the hot spots of the global warming, in this specific region, because the collapse of the ice shelves, because the warming we have observed, but there are other regions, and what we need to do, these are my scientific tasks, are following traverses like we have done in recent years. We went to South Pole, we went to the Pole of Inaccessibility, we went to subglacial lakes. We are doing ice core programs, and we would like to collaborate with other people in doing that. And in West Antarctica, we know that at least the Amundsen Sea glaciers are experiencing huge changes. And we hope to follow some urban campaigns with the P3 or maybe with the C-130 or with twin otters like the British are doing now in other regions of Antarctica. And in the peninsula, we know that there are many changes. And that's why we are working now together with the Chilean Air Force and INACH and the British in the Fleming Glacier and the Warty Ice Shelf. So in the future, we hope that we can contribute to the knowledge about this process, forecast about what's going on, will going to happen in the future, and maybe giving tools to you, that you are the decision makers, that to tackle this problem. Because I mean, I'm a scientist, what can I do? But maybe I can give some information to you and you can have the right decisions. But I think it's urgent to have these decisions. But we are living in a country where climate change is maybe third 10 priority, because we are living in a country with poverty, with inequalities. But the problem is that if you separate this kind of problem from, for example, global warming, you're not understanding, because the poorest are going to suffer most from these changes, because they are living in the worst places, because they don't have the technology, they don't have the education. So that's the main problem. Well, I don't want to bother you anymore. Thank you.